Okay, welcome class. We're going to go through properties of logarithms for this one, and then of course we'll keep having some more coming out, hopefully, so you have a bunch of stuff this weekend to look at and to help you complete topic 6 homework. We haven't gone over logarithms in class. That's actually tomorrow, but let's start with the properties and kind of work with these. This is not the beginning section. That's going to be what you're going to go through in class on Friday. All right. So in this section, we're going to cover and apply the product, quotient, and power properties of logarithms. We're going to write a logarithmic expression in expanded form, and we're going to write a logarithmic expression as a single logarithm. So we're going to both expand it and then try to put it together. Different times you may want to do either one of those just to make your life easy, or you may just want to type a bunch of times in the calculator if you're really good at entering these into a calculator, if you feel that's necessary. And then we'll apply the change of base formula, because surprisingly some calculators actually can't do that, so we have to come up with a formula that allows calculators to do that. All right, so let's start with the beginning. We're going to apply the product, quotient, and the power properties of logarithms. The properties of logarithms are in a handout that I gave that had properties of exponents and properties of logarithms, or I posted in the announcements. So here, b, x, and y are positive real numbers, and b can't be 1. Because 1 to any power, right? We kind of talk about that in the next section, in the previous section. So the product property says that if we have log with the base and we have two things multiplying each other, we can separate them and say that it's the log with the same base of one of the values, in this case x, plus the log of b to the power of y. So all we're doing is separating. If it's multiplication, we can separate them and have two separate logarithms with a plus. The quotient, kind of the same idea. In here we were dealing with logarithms that are multiplied and we added. Now we're going to divide, and instead of adding we're going to subtract them. That's really all there is to it. It's pretty straightforward. You do need to be careful of the order, because sometimes you'll have multiplication in here inside, so you'll have, like, I don't know, n x. So that's a multiplication and a division. You would do the division first to break it apart, and then over here you'd have nx, and then you break that apart like up here. So you can put lots of different things together this way. That means you can also take really complex ones and shrink them down, which is always nice. The power property says that the power up here basically just moves down in front. And this is very useful in clearing powers, if possible. And there it is here. So that becomes this. We're going to assume that all variables and expressions represent positive real numbers as we go. So let's try some of these out. So this is the product property of logarithms, to write the logarithm as a sum. And then, of course, we'll simplify if we can. We won't always be able to. So in this case, we have log. And again, as we've established, that's a base 10 because it doesn't say. And then we would write that as log of 2 plus log of x plus log of y. Pretty straight across. And here, if this one right here had been a log with a base of 2, this would have had a special property that we could have used, as you will have already seen, and that would go away. That's a hint for when you do your try. I'm not going to go over the tries. I'm going to do 2. 2 is a natural log, so ln. Again, the base here is e, and I have ln of 3 times a plus b, so that just becomes ln of 3. And I always tended to keep parentheses just as I'm working with them so I don't miss something. And then it's plus ln a plus b. There's no way to separate that. That is a single term. So this is a single term. So we need to keep that together. And that's really all there is. That doesn't separate any other way. And distributing the 3 through first doesn't really help you. And I know you may feel like, oh, well, what if I distribute it through first? Which is a valid idea, but it doesn't actually help you because it's still a plus in between them, and they're all inside the argument, so you really can't do much. All right, and then I'll let you guys do the log. Again, if you have questions, please reach out to me on them. But my guess is you'll be okay on it. Let's try some of these. So this is using the quotient property. We're going to rewrite them as a difference, and then, of course, we're going to simplify. So the first one, we have log, the base is 7 to the power of, or not to the power, to the z minus log base 7 to 49. Now this one we can simplify. Z, we don't know what that is, but here we've used we've learned the technique, so we can simplify this. 7 to what power is going to be equal to 49? And that would be 2. So this really becomes log 7 of z minus 2. Okay, so it's nice when we can simplify it. Don't always believe you will, but it is nice when you can. And that can help you in the solving processes as you're doing these. The next one, I'm going to do 2. Again, I'll save that try for you guys to do. Have some fun with it. And if you have questions, of course, ask. So in this case, I have log of 100 minus and log, and this is one term, right? It's the whole term that's dividing, so it's all of this that's dividing that 100, so it has to stay together. Remember, if we don't give the base is assumed to be 10. So that means 10 to what power is 100, and this is equal to 2. So this is equal to 2 minus the log of x plus y. Lots of fun. My hope is that by understanding how to do this, it's going to make your life easier as you deal with solving these. Remember, logs are just basically glorified exponents. They're an inverse of an exponential function. Excuse me. But we tend to use them specifically when our exponents are some weird, ugly decimal. Non-ending, not repeating sort of thing. Sorry. All right, so we're going to apply the power property. And so all we're doing is taking the 5 and we move it in front. So 5 times ln of x. And of course, we do want to simplify if we can. That should always be the case. We won't be able to here because we don't know what x is, but remember ln has a base of e, which will make a difference when you do your try. Here, we have to think about what this is, so I'm going to rewrite it first. Remember that a root, a square root, cube root in this case, roots are really exponents. That's all they are. So this says it's x to the power of 2/3. So the 2 here comes there, and the index comes here. And remember, if you don't see a number for the index, then it's assumed to be 2. So we have log of x to the 2/3 power. Well, then we can take the 2/3 power and move that down in front. So this is really 2/3 log of x. And again, it's still a base 10. So not real crazy. And you get a try. Again, if you have a question, please reach out to me or come into the Math Center. Somebody can help with answering these. All right, so we applied the product, quotient, and the power properties of logarithms. Now let's write a logarithm expression in an expanded form. So we're going to do expanded first, and let's do that. So now we have this logarithm, and we want to expand it out. Usually we're expanding because there's some property that we're going to be able to simplify out. In this case there isn't, because we're just starting with some simple ones to do the expansion. So this is equivalently, the division is happening, so I'm going to take this chunk and do division by this chunk. So this would be log, I have a base 3 of 5z minus log 3 of w, and then I can still keep breaking. So this is multiplication now in here, and that can become a sum. So this will become log base 3 of 5 and plus log base 3 of z minus log base 3 of w. And that is the answer to that. If I knew, maybe I'm going to be approximating, because in the real world that's what you do. Stuff doesn't come out pretty. So I may approximate this. If I knew, then I could, if I was easily accessible to whatever z and w was. This would be the process. Let's try another one. Again, here I have AC being multiplied, but the AC itself is being divided by 5d, so I can keep that together. So this becomes log of 7 of AC minus log of 7 of 5d, or 5d. Now I can separate these, and this becomes log of 7 of A plus log of 7 of C minus, and I always do this just because I want to keep everything together in the right order, log of 7 of 5 plus log of 7 of D. And then we can distribute this negative sign through to this term and to this term. So this would be written 7 of A plus log 7 of C minus log 7 of 5 minus log 7 of D. And there we go. Written out. Alright, what do we have? Oh yeah, here's one for you guys to do. This does have a power rule, so after you do the separation, remember that power rule right here. Other than that, it's pretty basic. So that'll be a try. Again, let me know if you have any questions. Oops, didn't want to do that. All right, so we got that. I'm going to go ahead and stop this one here, and then I'll move on to do the next two in a moment.